So coal-fired Rankine cycle steam plants, as we saw earlier, provide more than 40% of the total electric power to the U.S. And what we're going to do next is use this diagram to go through the typical operation of kind of a run-of-the-mill average coal-fired power plant. So the first thing is that we've got coal coming in from a coal yard. It's being conveyed in typically on a conveyor belt. It's number 14 here on your diagram. It's from this, being drawn from these external coal stacks. And then it falls into a hopper, a two-stage process where there's a hopper and then what's a pulverizing fuel mill. And what these do is they take these chunks of coal and they turn it into coal dust. So 15 the hopper and 16 the pulverizing fuel mill convert these chunks of coal into coal dust. The coal dust is then mixed with a preheated air. The preheated air here being shown number 24. There's air coming in. It's already gone kind of past this hot boiler system, so it's warmed up air. It's being pushed by this fan, which is often called the draft fan. And so down here, what's happening is the coal dust and warm air are combining here. And this hot, what is called an air-fuel mixture, is then forced kind of at high pressure and high velocities into this boiler, where it will meet the flame and rapidly ignite here inside the boiler system. Water of a very high purity, so it's very, very high resistance water, very clean water. It's going to flow vertically up the tube-lined walls of this boiler system that we're showing kind of in conglomeration here on the kind of the middle right side of the diagram. It's flowing through the walls of the boiler, so it turns into steam, and it passes through the boiler drum where steam is separated from any remaining water. The steam is going to pass through the manifold in the roof of the drum into what's called the pendant superheater, number 19 here, where its temperature and pressure are increased rapidly to around 200 bar and 570 degrees. So there's steam, high pressure, high temperature steam glowing in these kind of steel tubes here, still inside the boiler. And it's actually hot enough that you can see these tubes kind of like light up a little dull red color from the heat that they're carrying. The steam then, we can kind of see, you may see that it goes through this cycle and it is pumped down here to number 10, number 11, excuse me, which is called the high pressure turbine. This is the first of a three-stage turbine process here, turbine number 1. So 10 is actually the steam governor valve, which allows you to kind of control the flow of this high pressure steam into the turbine. It allows manual control of the turbine and then also automatic set point following. So it's actually how the output of the generator is controlled, is by this steam governor valve. The steam is then exhausted from the high pressure turbine, and it has been reduced at this point in both pressure and temperature. And so then what happens a lot of times is it's flowed back to a secondary system in the boiler called the boiler reheater, 21 here. So it's just a heat exchanger path that reheats the steam. And the reheated steam is then passed to what's often called an intermediate pressure turbine, number 9 here. So we see the steam path comes back to the intermediate pressure turbine. It spins that turbine as well. And then, then that lower temperature, lower pressure steam is fed directly to a low pressure turbine set here, number 6. So we've now basically used up all the useful thermal energy and pressure in this steam. It's a little bit above boiling point. It's then brought into thermal contact with cold water, which is being pumped in from the cooling tower inside of number 8, the condenser. And here, the boiling hot steam coming from the low pressure turbine is converted and condensed rapidly back into water. That creates the side effect of creating a near vacuum-like conditions inside of this condenser. And so actually the condensation causes a natural process by which the steam is sucked into the condenser through vacuum action. The condensed water is then pumped out of the condenser by a feed pump. It then goes through what's called a deaerator to remove any sort of oxygens or gases that have throughout this process gotten into the water, so it's going to remove those. It then goes, after the deaerator, it goes into a feed heater, 13, just kind of heats that condensed liquid up. It's not high pressure though, it's just warm. So this is a pre-warming stage in 13, which is again the feed heater, and all this is, by the way, powered by steam action. And then it's sent back to, you can see it's sent back to the boiler drum here. The lower section of the boiler drum, this preheating stage 23, is often called the economizer. It's bringing that liquid back up to temperature. Let's see. The liquid water, if we follow the path, the liquid water from the condenser is, from here, is often sprayed inside this big cooling tower that you see. So it's not a smokestack, it's a cooling tower. This creates a highly visible plume of water vapor. When you see what looks like smoke coming out of the stacks here, a lot of times it's actually water vapor. And that's actually part of the condensing cycle when it gets pumped back into the condenser unit and back into the cooling water cycle. The three turbines, 11, 9, and 6 here, the high pressure, intermediate, and low pressure turbines, they're all coupled on the same shaft, and then they connect to number 5 here, the three-phase generator. That three-phase generator typically will generate an intermediate voltage between 20 to 25 kilovolts. It actually depends on the generator design, so that's just a rough figure. The output voltage is three-phase. We can see red, blue, yellow, the three phases. It's stepped up at the generation site by a transformer to a voltage more suitable for transmission. 72 kilovolts or higher, up to 500 kilovolts or so, and then it's just sent out on this number 3, the three-phase transmission system. The boiler does have some exhausts associated with it. There are solid wastes that come out of the hopper and have to be collected. So this is the fly ash connection, fly ash collection here of the uncombusted coal that comes out of the bottom of the burner. Also, the hot gases, as they escape the burner, they go through, they're pulled by what's called a induced draft fan, and they go through an electrostatic precipitator. And the point of the electrostatic precipitator is to collect the ionized particles, and then there'll be the remaining exhaust is vented through these chimney stacks, 27, the chimney stacks. Sometimes increased amount of carbon dioxide and SO2 sequestration technologies are located inside of the stacks. Water technologies, different technologies that we'll talk about later, but there is sometimes a little bit more going on in that stack than just it being a tall chimney. Most of the coal-based generating units that operate according to the steam cycle in the U.S., they're pretty old. 20 and 55 years old is kind of average, with a fleet average, I think, of about 35 in the U.S. Newer technologies are more efficient, tend to be larger. So if they're less than 35 years old, they tend to be about 550 megawatts. Older units, we didn't have the engineering technology to build them as large, so they tend to be smaller than that. If you kind of look at the market for where coal technology is going, current life extension capabilities are probably going to extend the average lifespan probably another 30 plus years. Those older technologies, those smaller plants, are probably below 30%. Newer technology is about 36%. And what this map is in 2000, there was we put a plot up of the capacity and the distribution of coal-fired power plants in the United States, and they're organized by the total megawatt capacity, so how much electric energy that you can produce. And you can see, I mean, it's pretty clear, you got the Mississippi River running right down through there, and not that there aren't coal plants in the West, but coal is predominantly utilized in the eastern United States. You also have to realize that population density in this area of the country is much larger.